Okay, so our today's physics lecture is about significant figures. What is significant figure? Basically, significant figures help us to reduce or to small the digits or small to reduce the values. There are some rules we have to follow in significant figure. Rule number 1, that all non-zero digits can be called as significant figure. That any value or any digit having no zero in it can be called as significant figure. Example, 3279 have 4 significant figure because it has no zero in on left side or right side, so it can be called as significant figure. Rule number 2 tell us that zero between two non-zero digits are counted in SF. Zero between two non-zero means having no zero and number, so this is the non-zero digit and this is the non-zero digit, and zero are placed between these both. So we have to count these zeros. So the SF will be 5 SF, like 20106, the SF will be 5 SF. Rule number 3 tell us that if the number is less than 1, means in a point, 0 point, so we will count from non-zero digit. We will simply neglect the zeros on left side. So as you can see, 0.00123, this is the value less than 1. So we have to just simply neglect these zeros, and we have to count from non-zero digits. So non-zero digits are 1, 2, 3, and these are 3, so 3 SF. These 2 0 will neglect, so that will be 3 SF and 0.5. This 0 point will be neglected, so it will be 1 SF. Okay. Rule number 4 tell us that 0 without decimal point are not counted. Like 14,000, okay, it has no decimal point, so we will not count these zeros in significant figure. There will be only 2 SF, there will be only 1 SF. Okay. Now rule number 5, 0 after the decimal point are counted in SF. 0 after the decimal point, here is no decimal point, that's why we are just neglecting these zeros. There is a point, so we will count these zeros in significant figure. As 1.004 will be 4 significant figure, 1, 2, 3 and 4. 2.600 there will be 4 SF, and 1.30 there will be also 3 SF. Okay. Now the rule number 6, if the value is in power, means in the exponent form, we will not count that power, we will simply neglect them and count the numbers, means count these numbers. So 3.82 into 10 to the power 8, we will simply neglect the power, whatever power we will just neglect it, we will not count in SF. So 3.82, these all are the non-zero, so it will be 3 SF. These all are the non-zero, it will be 4 SF. All these 3 and 2. Okay. Now rule number 7, it's for the constant, means G, smaller g, capital G, K, H means mu, this is the mu, spring constant, and this is the pi, means the constant values. These all are the constant terms, so we will show them with the infinity symbol, or by writing the infinity or by the infinity symbol. That if the value of pi is, for example, if the value of pi is 3.14 and so on, it's going on, so it has no end point, so we'll just write here simply like infinite, or by the symbol infinity. Okay. Constant have no significant figure, because constant term have the how we can find that these both are in the decimal on the exponent form. So how we will know that which one is the constant and which one is the exponent form, we have to find. So in a constant we have a solid, or we can say the basic unit with them, like speed of light. So the speed of light is equals to 3.8 into 10 to the power 12, I think. into 3.8 into 10 to the power 12. So 3.12 into 10 to the power 8. I think so this is the speed of light. So we will just meter per second. It has a basic unit here. It has a unit here, so it will be constant, and the speed of light will be equal to infinity. And if we will write any term without constant power or without any unit, so it will be called as this exponent form, and we will just neglect the power. If there is a given the unit, so we will count as a constant is equal to infinity. These 7 are the rules of significant figure. Okay,